Hello student, hope you all are doing great and you are fine. So in today's lecture, we are going to study basically the motion in a straight line, class 11 physics. So let's get into it and let's understand everything, okay? So first we will study here the motion in a straight line. What is the motion? Then get to know the motion in a straight line, what is that means? And also after that, we will study about the distance, displacement, and after that we will get to know about the velocity, what is speed, and then acceleration, and also the equation of motion. We have three equation of motion. Also derive that graphically. So let's get into it. Firstly, let's understand the motion. Okay, so what is motion basically? Motion is nothing. Basically, it is a change in position with respect to time. Means if one car is at a point A and after some time t interval, they move to at a point B, and for that region, their position is changing with time. That's we can say that the motion car have the motion. Okay, in one word. Okay, so here let's understand. Here we have right, we will get to know about this 11th physics. The topic is motion in a straight lines. Okay, so you can see here, right here you can see here this straight road. We have three cars, one two three. Okay, moving in a straight line. Okay, so we can say that this is a straight road basically. That's why we can say the straight line motion all three cars have. Okay, my name is Rahmatullah, as you know that already. So let's understand the motion as we have defined already in the first, that change the position of an object with respect to time. Means time ke with respect to time there will be change in position. Means if a car at a at time t1 and at time t2 or let's say t1 is 1 second and t2 is 2 second. Okay, 2 second, let's say the position is changing. This is the position of B. Okay, this car, one car is from moving from this point to this point, then the position is changing obviously with time. So we can say that this car have motion. Okay, in simple, in this chapter basically we will going to study the motion in a straight line. Means there will be no concavity. Means there will be no concave type, or we can say the curvature type of road or anything. There will be a straight road. Okay, so motion will be in a one dimension, we can say in another word. So, and this also motion we call it as rectilinear motion. We can say this is the also called as rectilinear motion. Here we can see the types of motion. Here we are going to study only straight line motion. This is the rectilinear motion, or we can say straight line motion, and this is the circular motion. Why? Because object is moving along the circular path. That's why we are calling it as circular motion. This is, let's say this is the center. Our clock, wall clock, is also the needles of the clock. Like we have three needles. One is second, one for the minute, and other one for the hours hand. Okay, so all these are rotating in a circular motion. Okay, or we can say the moving in a circular motion. This needle or this needle is moving in a circular motion. And we have the ball. Here we have ball, either it is footballs or we can say the cricket ball. They also rotate, or we can say the spin about their axis. Okay, sorry. So basically this is the rotation motion, kind of rotation motion, because as you know that the cricketer spin the ball so that the batman cannot hit the ball. Okay, sometimes it happens, as you know already, that the spinners are also there in cricket team. So they rotate the balls in such a way that spin. Okay, and we have the periodic motion, like we have pendulum is also kind of periodic motion. So basically to and fro motion will be there. Means at a regular interval of time their motion will be repeated. Okay, this is the example, like the periodic motion. One we have, like we have a watch, and underneath of this we have a pendulum kind of things. They to and fro motion, do that to and fro motion, or we can say the back and forth motion will be doing this. Okay, this pendulum. Okay, and basically here we will get to know about the straight line motion. So let's understand about now the distance. Okay, this is the distance, displacement. Now let's understand distance. Distance is basically the path traveled by an object, or we can say the car. Okay, if an object or either a car, or we can say a truck driver or truck or anything we have, like, or a train. So if a car or train, anything, any object, moving object, moving from one point to another point, they must have to trace a path. Okay, so that path, the distance of that path is, we can say, this is the distance. Okay, so the total path covered by the car, okay, or the path travel, okay. We can say the distance. Let's say the example of here. Let this biker is at this tree, okay, close to this tree, and he wanted to go to this house, okay, at point B, and after that they wanted to go to this tree at point C. So first they want to go to this house and close to this house, and then for this point C, okay. So how much the distance forward? Basically the distance forward will be the path. First one is the AB path and then BC path. So AB path, distance of AB path we have is 4 meter, and distance of BC path we have is 3 meter. So total distance covered by him is 7 centimeter, basically meter. Okay. While they can also reach this point C, or we can say the tree, by the shortest distance, by traveling the shortest distance from A to C. So that is called, we call it as displacement. Basically displacement is nothing but it's a shortest distance from initial position to the final position, okay. So this is the basic definition of the, or we can say the basic differences. And the distance is a scalar quantity, that's why they doesn't have direction, only they have magnitude. But this displacement have a specific direction, that's why we can say that this is a vector quantity, okay. So the specific direction will be only, the shortest distance will be covered only in specific direction. So this is the major difference between them, and the distance cannot be zero, we can say, or we cannot say the distance will be negative, while we have displacement that can be negative also, and also that can be zero. So it depends upon the initial and final position, okay, as it is a vector quantity. And the SI unit both have meter, both have SI unit meter, and distance will be equal to distance when one object, or you can say a car or a truck driver is moving in a straight line. That means if a car moving from this point to this point, then we can say that this is a straight line motion, okay. So the distance or displacement will be same. Now come to this the slide. Let's understand the component of a vector, okay. So basically here we will get to know the component of a vector along only x-axis, only one direction, because as you know we have three dimension in the 3D axis, okay. So the first one is the x-axis, another we have y-axis, and other third one we have z-axis. So in 3D object we have three axes, but if we study in a straight line motion, so we have to understand the one line, or we can say one axis motion, okay. So here we have draw, this one is the x-axis, this one is the x-axis, this is, let's say, the positive axis of x, and this side we have negative, from this zero, counting from zero is the negative x-axis, okay. So we here we assume I is the unit vector for x-axis, and j is the unit vector for y-axis, and k is the unit vector for k-axis, or we can say the z-axis, okay. So here we use to only the I-axis, or we can say the x-axis, okay. I is the unit vector along x-axis. What is unit vector? First we have to understand, basically unit vector is nothing but its magnitude is 1 in a specific direction. So our specific direction here is x-axis, simply, okay. Our specific direction is x-axis. For the positive x-axis we denote only capital small I, or for the negative x-axis we denote minus of I, just multiply with minus, okay. And if you want to write a vector with some magnitude, just write unit vector with that magnitude, okay. Let's say we have a displacement s is equal to of 5I. That means we have 5 magnitude of, or we can say the 5 meter or 5 centimeter of distance covered along x-axis. We can see here, okay. So basically here we can see that the one dimension vector can be constructed in that way. Just multiply the magnitude with I cap, or that direction, okay. So that will form the vector. Now let's understand the velocity and the speed. So what is velocity? Basically velocity is nothing but it's a rate of change of displacement, basically with time, and the speed is nothing but it's a rate of change of what? Distance. Basically we can say the displacement per unit time simply, or displacement divided by time, we also call it the velocity, okay. And that means displacement have direction and magnitude. Similarly, this is the rate of time, so this will also have a direction and also a numerical value, velocity have, okay. So let's say v is equal to 5 meter per second, okay, I gap, okay. That means velocity of 5 meter, or we can say the speed of 5 meter per second along x-axis. Now get to know about the speed. Speed is a scalar quantity, right? And this has only the magnitude, and that doesn't have direction, specific direction, and it is the rate of change of what distance. That's why we can say by definition this is the distance covered per unit time, or we can say as by t, as is the here distance and t is the time. Okay, so here we can see there that no direction and only have magnitude, and this is a scalar quantity. That's why. Now get to know about the types of speed, and now after the type of velocity, right? So let's say if an object is at rest, that means the speed is zero, or we can say the rest condition. If an object is under the motion, or we can say at a time t, let's say at time t, we just wanted to know what is the speed. That is called an instantaneous speed. Okay, at any time, like right, that for current time, let's say t is equal to 5 seconds. What is the speed? If one car is moving from A to B, okay, they must have changing their speed at some time 5 at equal to 5 seconds, that have must have some specific speed. Okay, so that speed is called instantaneous speed, means at that instant what is the speed. Okay, so the first one we have is rest condition, or no change in motion, or the car doesn't have motion, or we can say the object doesn't have motion. That is the rest condition. And second we have instantaneous speed, or that means at time t they have must have the speed. Okay, and one we have third one we have is average speed. Average speed is nothing but is total distance traveled by total time taken. Simple. Basically it's a kind of mean speed, we can say also. So it's a total distance. Here you can, by definition, distance traveled by time travel. Okay, or we can say the total distance by total time taken. And speed can be of uniform and non-uniform. What does that means? Uniform speed. Okay, speed is uniform. What does that means? It can be uniform or non-uniform. Non-uniform. So uniform means the speed will be constant. The speed is constant. Okay, speed is constant. Let's say the speed of v is equal to 5 meters per second. This is constant throughout the motion. That means the uniform speed. Okay, and if speed is changing, right? Let's say car moving from A to B point, but their speed is no constant. That means at this point is speed different, at this point is speed different. That is non-uniform motion. Simple. Now come to the types of velocity. Similarly, just here the rest condition will be there, instantaneous velocity will be there, and also the average velocity will be there similarly. Okay, here, but that have direction. Just the difference is that. So we can say by velocity, we can also define velocity as this is the distance covered in specific direction, any specific direction. That is also called velocity. Okay, and the velocity has also the conditions of like rest condition, and second one we have is average velocity, and third one we have is instantaneous velocity. By definition we can see there. Now now come to the mathematical definition of instantaneous. We can say the velocity or speed. Okay, so basically let's say v is the instantaneous velocity. We can define as lim, or by full, this is the lim is the short form of limit. Okay, so let's say at delta time t, very small time t, delta t is around tending to 0, means very little time interval, there will be change in displacement. Let's say that is delta x in the in time interval of, in which time interval, in delta t. Okay, delta t. Okay, this is the definition of instantaneous velocity. Also we can write as dx by dt. Basically this is the small change. Okay, dx is very small change in x, and dt is the very small change in time. Okay, we can say that this is the derivative of x. Okay, time derivative.